This is section 9.2, part A, carrying out a significance test. Confidence intervals and significance tests are based on the sampling distribution of statistics. That is, both use probability to say what would happen if we applied the inference method many times. In section 9.1, we presented the reasoning of significance tests, including the idea of the p-value. In this section, we will focus on the details of testing a claim about a population proportion. So in section 9.1, we met a virtual basketball player who claimed that they made 80% of their free throws. We thought that he might have been exaggerating. In a simple random sample of 50 shots, the player made only 32. His sample proportion that he made for free throws was then 64%. This result is much lower than what he claimed. Does this provide convincing evidence against the player's claim? To find out, we need to perform a significance test. So our null hypothesis is that P equals 80%. The alternative is that it is less than 80%, where P is the actual proportion of free throws that the shooter makes in the long run. In Chapter 8, we introduced 3 conditions that should be met before conducting a confidence interval for an unknown population proportion. You need to check that it's random, normal, and independent. These 3 conditions must be verified before carrying out a significance test. Now, when you're talking about a proportion, to check the normal condition, you need to do the sample size times the probability of success and the sample size times the probability of failure, and the number of successes and the number of failures must at least each be 10. Since we assume that the null hypothesis is true when performing a significance test, we use the parameter value specified by that null hypothesis. Sometimes we're going to call that P sub 0. When checking the normal condition, in this case, the normal condition says that the expected number of successes is going to be n times P sub 0, and the number of failures will be n times 1 minus P sub 0, and both of these are at least 10. So we're going to go ahead and check our conditions before we can carry out a significance test. So we're still dealing with this same situation. So if we check our random first, we can view the set of 10 shots as a simple random sample from the whole population of all possible shots the virtual shooter can take. To check to see if it's normal, we are going to assume that our p-value is 80%. So 50 times 80% gives us 40, and n times 1 minus p, which in this case would be 20, is going to give us 10. Both of these values are at least 10, so the normal condition is met. The last thing we need to check is for independent, and remember it needs to be the 10% condition. We can assume that the shooter is going to take more than 500 shots, so that 10% condition is met because we can just do as many as we want because this is a virtual shooter. If the null hypothesis is true, then the player's sample proportion p hat of made free throws in the simple random sample of 50 shots would vary according to an approximately normal sampling distribution with a mean for the sampling distribution of 80%. And to find our standard deviation, we would still do the same stuff we've been doing for the last couple of chapters. We're going to do the square root of our probability of success times our probability of failure all over the sample size, which for our sampling distribution in this case would be 0.0566. The figure below displays the sampling distribution. We have added the player's sample result. So this is our sampling distribution in the whole. We have our center is that 80%. We used our standard deviation to create our distribution here, and then the value that we got for that one sample is all the way down here. So to calculate what that statistic value is, a significance test uses a sample data to measure the strength of evidence against the null hypothesis. Here are some principles that apply to most tests. The test compares a statistic calculated from a sample data with the value of the parameter stated by the null hypothesis. values the statistic far from the null parameter value in the direction specified by the alternative hypothesis give evidence against that null hypothesis. To assess how far that statistic is from the parameter, standardize the statistic. This standardized value is called the test statistic. So in our test statistic, it's very similar to finding the z-score. You're going to do your statistic minus the parameter all over the standard deviation of the statistic. Very, very similar to x minus mu all over sigma. A test statistic measures how far a sampling statistic diverges from what we would expect if the null hypothesis was true in standardized units. The test statistic says how far the sample result is from the null parameter value and in what direction on a standardized scale. You can use the test statistic to find the p-value of the test, as the following example shows. So in our simple random sample of 53 throws, the virtual player made 32. Calculate the test statistic. Before we can do this, we already checked, but if this was a normal case, you would need to check to make sure that all the conditions were met. So you would need to check that it's normal, so the number of failures and number of successes are each at least 10. You would need to check that it's random, and you would need to check that it's independent. Now we've already done this when we did that previous example to make our bell-shaped curve, but on a normal situation, you would need to check this. Now in this case, we know that our p-hat is 32 out of 50, or 64%. We know that our p-value is 80%, and we've already found it, but you would need to find normally the standard deviation. So remember, that's going to be p times 1 minus p all over n, which would be 80% times 20% all over 50, which we had previously found to be 0.0566. So to find your test statistic, you are just going to do your statistic, which is your p-hat, minus the parameter, which in this case is your p-value, all over the standard deviation. And this is going to give you negative 2.83. This is the z-value for this one. We're doing a test statistic. This is basically just your z-value. Now, find and interpret the p-value. The p-value is the area on the table. So, on our standard normal curve, if I'm at a z-value of negative 2.83, remember table A tells us the area to the left of this. So, if you look at table A and you look up the z-value of negative 2.83, you are going to find an area to the left of that of 0.0023. So if the null hypothesis is true, the player makes 80% of the free throws in the long run. There is only about a 2 in 1,000 chance the player would make as few as 32 out of 50 shots. So this is our p-value in this case. And we are interpreting it by saying that this means in 2 out of 1,000 chances the player would make as few as 32 of 50 shots. Earlier, we used simulation to estimate the p-value as 0.0075. As the example shows, the p-value is even smaller at 0.0023. Either way, it's very unlikely that an 80% free throw shooter to make 32 or fewer shots in a simple random sample of 50 attempts. This result confirms our earlier decision to reject the null hypothesis and to conclude that the player is exaggerating. So if we need to do a significance test as a 4-step process, remember the first thing is going to be your state. So what hypothesis do you want to test and at what significance level? and define any parameters that you are going to use. So all of those things need to be in your state. Your plan, you need to choose an appropriate inference method. So are you going to do a one sample Z test, a Z interval, a T interval? What are you going to be using? And you need to check those conditions. In your do, if the conditions are met, you will perform your calculation. So you'll compute your test statistic, and then you will find your P value. And then in the conclusion, you will interpret the results of your test in the context of the problem. So when the conditions are met, remember your conditions are random, normal, and independent, the sampling distribution of P hat is approximately normal with a mean of P and a standard deviation that is given. For confidence intervals, we substitute the P hat for P in the standard deviation formula to obtain the standard error. When performing a significance test, however, the null hypothesis specifies a value for P, which we will call P sub 0. So we assume that this value is correct for performing our calculations. We standardize the statistic P hat by subtracting it from the mean and dividing it by the standard deviation, and we get the test statistic. Or we can basically call this the Z. The test statistic is just giving your Z value, which you'll look up in table A to find the area to get your P value. So you're going to do your sample or your statistic, your sample proportion in this case, minus the P sub 0, which is your parameter at the null hypothesis over the standard deviation using that null hypothesis. This Z statistic has approximately the standard normal distribution when the null hypothesis is true. P values, therefore, come from the standard normal distribution. So if we are going to do a one sample Z test for a proportion, you're going to choose a simple random sample of size n from a large population that contains an unknown proportion P of successes. To test the hypothesis of H sub 0, where P is equal to P sub 0, compute the Z statistic. You're going to find the P value by calculating the probability of getting a Z statistic this large or larger in the direction specified by the alternative hypothesis. So if our alternative hypothesis says that it's greater than, you are looking for the area to the right. If it says less than, you are looking for the area to the left. And if it says not equal to, you are actually going to look for both directions. Use this test only when the expected number of successes and failures are both at least 10 and the population is at least 10 times as large as the sample. So make sure you check that normal and the independent conditions before you start. So let's go ahead and perform a significance test about P. So the potato chip producer in section 9.1 has just received a truckload of potatoes from its main supplier. Recall that if the producer determines that more than 8% of the potatoes in the shipment have blemishes, the truck will be sent away to get another load from the supplier. A supervisor selects a random sample of 500 potatoes from the truck. An inspector reveals that 47 of the potatoes have blemishes. Carry out a significance test at the alpha equals 10% level. What should the producer conclude? So the first thing we need to do is do our state. So we want to perform a test at the alpha equals 0.10 significance level. Make sure when you're doing your state, you always state the level, you state your null and alternative hypothesis, and what your parameter actually means. So we're performing this at an alpha equals 0.10 significance level. Our null hypothesis is that P equals 8%, and an alternative hypothesis is that it's greater than 8%, where P is the actual proportion of potatoes in the shipment with blemishes. So again, in that state, you need to give us the alpha level, you need to give the null and alternative hypothesis, and you need to tell us what that parameter is talking about. For the plan, you need to tell us what test you're going to do, and then you need to check that the conditions are met. So if the conditions are met, we should do a one sample Z test for the population proportion P. Now we need to check the conditions. So random, The supervisor took a random sample of 500 potatoes from the shipment, so that part is met. For the normal, we're going to assume that the null hypothesis is true, and so we're going to let our p sub 0 value be 8%. We're going to do n times p sub 0, or the number of the sample size times the probability of success, which will give us 40, and the sample size times the probability of failure, which will give us 460. Because both of these values are at least 10, we are safe to do our normal calculations. And then we need to check independence. Because we are sampling without replacement, we do need to check that 10% condition. It seems reasonable that an entire truckload of potatoes will be at least 5,000 potatoes, so we can say this independent part has been met. Next is the do. This is where you do your calculation. So from our sample, we know that 47 out of the 500 were blemished, which is 0.094. You are going to do your test statistic or your z value. So you are going to, if you want to find the standard deviation by itself first and then just plug it in, then it's basically just like your x minus mu all over sigma, or you can just do it all at once. So we know our p hat value is 0.094 minus our null hypothesis proportion of 8% all over the standard deviation, and that's going to give us a z value of 1.15. Now we are looking for the alternative, which is p is greater than 0.08. So we want to find the probability that z is greater than 1.15. Now remember, on table A, it tells us the area to the left of that z value or the area less than. So we're actually going to get an area of 0.8749. To find the area to the right of that, the whole curve is 1, so we would do 1 minus the area to the left, and it's going to give us an area to the right of 0.1251. Now the alpha level we picked was 0.10. Since our p-value is greater than our alpha level we chose of 0.10, we're going to fail to reject that null hypothesis. There is not significant evidence to conclude that the shipment contains more than 8% blemished potatoes. The producer will use this truckload of potatoes to make potato chips. This preceding example reminds us why significance tests are important. The sample proportion of the blemished potatoes was p hat equals 0.094. This result gives us evidence against the null hypothesis in favor of the alternative. To see whether such an outcome could occur just by chance when that null hypothesis is true, we carry out the significance test, and the p-value tells us that a sample proportion this large or larger would occur in about 12.5% of the random samples of 500 potatoes if that null hypothesis is actually true. That is, we can't rule out sampling variability as a plausible explanation for getting a sample proportion at least this much greater than 8%. When you go to take your AP exam, when a significance test leads to fail to reject the null hypothesis decision, as in that past example, be sure to interpret the result as we do not have enough evidence to conclude the alternative hypothesis. Saying anything that sounds like you believe the null hypothesis is actually true will lead to you losing credit. So make sure you never say that the null hypothesis is true or you believe the null hypothesis is true. Always just say that you failed to reject the null hypothesis. What happens when the data don't support the alternative hypothesis? Suppose the supervisor had inspected a random sample of 500 potatoes from the shipment and found 33 were blemished, which is only 6.6%. Such a sample does not give evidence that supports the alternative hypothesis that P is greater than 8%. There is no need to continue with the significance test. So if the conclusion is clear, we should fail to reject the null hypothesis. This truckload of potatoes will be used by the potato chip producer. So basically, if you find that your sample is smaller, if you're looking for p-value is greater than, and you find your p-hat value is less than your null hypothesis, you don't have to carry out the significance test. You can go ahead and just fail to reject your null hypothesis to start with. Always check to see whether the data gives evidence against the null hypothesis in the direction of the specified by the alternative before you do any of your calculations. Now, good news, you can do some of this on your calculator. One proportion z-test on the calculator can be used to test a claim about a population proportion. So we're still talking about those potatoes. We're still talking about p-value, or p sub 0 value is 8%. In this case, we're doing a sample size of 500, and we're revealed that 47 have blemishes. We want our significance level to be 0.10. So to perform the significance test, you're going to hit the stat button. You're going to go over to test. You're going to choose option 5, which is one proportion z-test. And you're going to enter the values for p sub 0, x, and n, which in this case, our p sub 0 would be 0.08. Our x value would be 47, the n value would be 50, and then you're going to specify the alternative hypothesis as your proportion is greater than p sub 0, and then you're going to select calculate. Now, let's check our understanding. According to the National Campaign to Prevent Teen and Unplanned Pregnancies, 20% of teens aged 13 to 19 said that they have electronically sent or posted sexually suggestive images of themselves. The counselor at a large high school worries that the actual figure might be higher at this school. To find out, she gives an anonymous survey to a random sample of 250 of the students in the school has 2,800 students. All 250 respond, and 63 admit to sending or posting sexual images. Carry out a significance test at the alpha equals 0.05 significance level. So first you're going to state what we're trying to solve. So remember, you need to tell me what the significance level is, the null and alternative hypothesis, and then you need to define your parameter. So we want to perform a test at the alpha equals 0.05 significance level of the null hypothesis is that p equals 20% and the alternative is that p is greater than 20%, where p is the actual proportion of students in the large high school who have sent or posted sexual images. Next is our plan. You need to say what type of test you are going to run, and then you need to check your conditions to make sure you can run it. So if the conditions are met, we should do a one sample z-test for the population proportion. Now remember, your three conditions are random. The counselor took a random sample of 250 students. To check normal, since we're talking about a proportion, you are going to do the number of successes times the probability of success, and the number of the sample size times the probability of failure. Both of these need to at least be 10, which in this case there are 50 successes and 200 failures, which are both at least 10, so we're good for the normal condition. And independent, they tell us that there are 2,800 students in the school, so 250 is clearly less than 10% of the population. Next is when you're going to actually do the calculations. So the first thing you need to do is you need to calculate your sample proportion, which in this case is 63 out of 250, or 0.252. Next, you're going to find your z-value or your test statistic. So you're going to do your statistic minus the parameter all over the standard deviation, and that's going to give us a z-value of 2.06. Now we are looking for the probability that it is greater than that. So 2.06 would be about here. Remember that your area under the table is going to tell you the area to the left of that. So the area to the left of that is 0.9803. But to find the area to the right of that, probability that it's greater than, is going to be 1 minus the probability to the left, which will give us 0.0197. Now we need to conclude. So this is why we had to pick that significance level at the beginning, because you're going to compare this p-value to your significance level in the conclusion. So since our p-value of 0.0197 is less than the chosen significance level of 0.05, we reject the null hypothesis. There is significant evidence to conclude that the number of teens aged 13 to 19 who have sent or posted sexually suggestive images is greater than 20% in this school.